Good morning, my friends. Today we're going to talk about a warp drive, and I think we can make one today. And I will show you right this instant how it's done, and I don't think it's hard at all. And I think it can go faster than the speed of light, and I don't think there's any speed limit to it whatsoever. This is why I make these statements. That is a red laser light. It is crashing into all these little white particles because those little white particles are free electrons in the air. And they are free electrons that would collect on you, leave the air, and go to you if it was dry in the air and it was moist on you. They like to be attached to water molecules. So any moisture in the air at all, these are going to be in there, but they also attach to other things. They're free to go where they want. That's how lightning comes through. That's how electricity flows through wires. There's free electrons in virtually everything, and especially in the air. So this little tiny particle is concussing with the air. And you say that's light, and light can only go at that speed. Well, let's discuss that. Now, this is that same disk, and that is that little particle of light that I was talking about. And the reason this is such a big region is because it is crashing into all of the field that's ahead of it, creating these fields. Now, it's quite obvious that that is a little white particle. It is not a wave, it is a particle. Those particles are concussing with each other at our accelerator. And this is the warp drive. Now, let's discuss why I say that. I can tell you right now, and I can see it very, very plain, and you can as well. These are reverse concussion waves. You see it? This is coming this way. It should be concussing only in this direction, as it was in the previous picture. But now it's concussing reverse. And that is because of the acceleration. And therefore, this spray is extremely high speed, and it is crashing into whatever is behind it. And guess what's behind it? Light. Light particles fill space, and they are the same particles as these, only they're not excited. And they're just floating through space or traveling or zipping around, whatever they do. But they are out there everywhere, and that is ether. And if you don't understand ether, you should now, because I have just shown you light is a particle. That's not a wave. That is a particle. It's not a flapping nothing. It is a particle. And I will show you the actual particle, because when it comes out of this accelerator, it begins to slow down. And when it slows down, it presents itself just instantaneously, and then it's gone. Well, it's gone down to its normal speed, and you no longer can see it. The particle I'm referring to is this particle right here. The accelerator is over in this region. As it comes through, it presents itself in two fields, approximately, and they are dipoles. Light is a dipole. All right, not only is it a dipole, it's obviously a particle. So, as I said, this is the concussion wave coming through the air. You don't see any reverse waves. This one here, you saw the tremendous reverse waves. That's because it's become an acceleration device. And if it sprays out the back, it will accelerate forward. And I'm going to show you in a little drawing that I made up. And of course it creates Higgs bosons, which we've seen quite obviously. And then you see the Higgs fields, and there's a white particle here that spun backwards and could be antimatter. It concussed with one of these Higgs fields and created this little particle, whatever that is. Then you saw the dipole electrons, and I'm saying these are electrons. They're not waves of nothing. They are electrons. Everything. These are all free-floating electrons. This is an electron spinning to the right, and this is a blue one, which is the high speed. So the boson section is longer, and you can see. Well, I'm going to open it up here a little bit. You can see that it's open here and compressing as it's slowing down, and then it'll create these Higgs fields, which are these ones. Are these ones up here as it crashes into the ocean of ether, which is the Higgs ocean, they call it now, which is nothing more than the air and all these extra electrons in it. And then the electrons set up polar fields, just like they do in a wire. If you put iron filings around a wire and ran it through there, you'd see the same fields. Plus, minus, plus, minus, plus, minus, plus, because it's moving and creating this spiral pattern. It's the right-hand rule. North Pole's that way, the field goes this way. That's the right-hand rule. And that's what we got here, is all these creating little Higgs fields. So let's go see how our plasma engine is going to work. All right, I showed you the different types of pictures that those pictures are by Rodney Warren. I do the same stuff, but he's fabulous at making the pictures, so I'm using his actual pictures. And he is the one that came up with this Venturi quite by accident. And this is all it is two little rounded sections like an airplane wing back to back, and then I would make it where it was tunable, so you could push them in and out, each one of them, so you could vary that gap. The other thing you could do is make them so that you could make longer ones or shorter ones or flatter ones, or whatever you wanted. There's a lot of architecture can go on at that particular Venturi, but all it is a Venturi. And by that I mean it does the exact same thing as a water hose. The water hose comes in and it has forced into a small, and it sprays out fast. It's as simple as that. You put in light from the front into a blue laser, and I would say blue because that is the short frequency. See, there's different frequencies. Let me explain this to you. Blue light is up on the top end of in the low end of the spectrum. It's a very fast particle, spins fast. And they're spinning particles, they're not waves of nothing. So the blue one is an actual blue particle that spins to the right. It's a dipole, and it's a very fast spinner. Then you have the green, which is a longer spin, and it's still quite fast. And then you have the red, which is the slowest. And that's the red, blue, green. Those are leptons. We actually photoed leptons too. Let me show you this. This is hard to believe, it's true. That is full spectrum light, sunlight. That is a half of a Venturi, and you can see that the field is spinning off. Here it is over here as well. It's actually tumbling. And here is the blue, green, red, blue, green, red, blue, green, red. And you can see they are spread out in these shorter and longer wavelengths. All right, that picture I just showed you was by a friend of mine, Renz, over there in France. And this is by another friend of mine, Fabian, who does this kind of research. He's picking up on it too, and he's got red and green. Now, what has he got here? He's got that red crashing very quickly and the green going out longer. See how it just stops like dead. And this spins faster and further and has more obvious impact power and carrying power. That's a blue laser, and man, that's a powerful laser, but it's not a high, we're not running at a high voltage. All right, this is a killer. You don't want to be in front of this one. Boom, that's green. And this one here, that's the blue again. All right, there's the red. Now the red just doesn't have the power of the other ones because it's a long frequency. But anyway, I just wanted to see the difference in them in the darkened room. And I tell you, you got to be careful with those lasers. I hurt my eye. I hurt an eye. I was trying to look at something too close, and just could that green one put your eye out just like that. You got to really be careful. Now, anyway. This is what I'm going to call a light plasma warp drive Venturi engine. It's as simple as that. You get a tiny little engine like this. You run light into, you excite the laser crystal, whatever you're using here, to create this laser. Now, and you can harvest this from space, I think, to make this run. I mean, they have the solar sails and all that, so, why not? Now, you can be shooting this and creating that plasma and shooting out the back. It's as simple as that. Simple as that. You tune it. You can tune this in and out and change different structure of the Venturi, and to deal with the different input. Depends on what you're getting in. But this is you're exciting the light and you're harvesting it from space, this here. So I'm telling you, this should be free. That's the electron volt power. That's how much power each electron has. Increases as you go from the red to the green to the blue. It just has more spin, more impact. Voltage is nothing more than electronic impact. And it is these negative particles, which are our light particles, impacting with the negative particles that are in space, which is light. Because that's light. I showed you the red light is light. I showed you it's a particle. Light coming from the sun is all kinds of different colors, but it is also light. It's also light. So it's also a negative particle. We live in those negative particles. They won't hurt us because they're so small. They're 1,800 times smaller than a proton. So we can live in those. That's okay. But you start getting hit with protons, you get hit with like basketballs and cannonballs. That's the whole different story. But this will drive you. This should drive you because it's pushing against all of its own type of particles, which are electrons floating in space. Negative particles, until you reach warp speed. So, final statements. Space is filled with negative particles. That is the light that is emitted from every luminous source. No question about it. Laser is negative particles. No question about that. I showed that in the experiment, the red laser. Therefore, you end up with repulsion between the particles in space that are negative and the particles coming out of the laser that are negative, and they are going to cause you, therefore, to accelerate. Could you go faster than the speed of light? I don't see why not. I don't think there is a speed of light. Because I showed you in our experiments, we exceeded the speed of light right here with a just simple little Venturi. So there's a lot